Once again, for part P, we're focusing on solving equations involving perfect squares and other factoring techniques as well. How can factoring be used to design a pavilion? The senior class has decided to build an outdoor pavilion. It'll have an 8-foot by 8-foot portrayal of the school's mascot in the center. The class is selling bricks with students' names on them to finance the project. If they sell enough bricks to cover 80 square feet and want to arrange the bricks around the art, how wide should the border of bricks be? To solve this problem, you need to solve the equation 8 plus 2x squared equals 144. When we square a binomial, the pattern is first term squared, first times second times 2, so plus 32x, plus the second term squared. Now we like to have things in descending order, so we're used to having it. And let's subtract 144 from both sides. Now I can see everything is divisible by 4. So I need factors of negative 20 to give me a sum of positive 8. So I need x plus 10, x minus 2. 10 times negative 2 is negative 20, and 10 plus negative 2 is positive 8. So that gives me two solutions. X equals negative 10, not likely in this situation, doesn't make sense. X minus 2 equals 0, add 2 to both sides, so x equals 2. So the question was, how wide should the border of bricks be? The answer is 2 feet. So when they ask us to solve, the first thing I'm going to notice is, hey, that's a perfect square, that's a perfect square. I'm guessing this is a perfect square. So square root of 4x squared is 2x, square root of 81 is 9. And just checking out, 2x times 9 is 18x, times 2 is 36. So it is a perfect square. So now I can just take the square root of both sides, and I have 2x plus 9 equals 0, and we're home free. Subtract 9, divide by 2. So this time we're only going to get one answer because it's a double root. It's an answer twice, but we only list it once. We should probably formally explain the square root property that I just kind of snuck in there and used. For any number, n is greater than 0. If x squared equals n, then x equals plus or minus the square root of n. So we didn't have to worry about the plus or minus on that one because negative 0 is still 0. But if we have x squared equals 9, x could be positive 3 or negative 3 because negative 3 times negative 3 is also 9. So they've set this one up very nicely for us. We have a perfect square already on the left and a perfect square on the right. So I can take the square root of both sides. I have b minus 7 equals plus or minus 6. Add 7 to both sides, and we get b equals 7 plus or minus 6. Now these are nice rational numbers, so we can go ahead and add. 7 plus 6 is 13, and subtract 7 minus 6 is 1. So our two answers are 13 and 1. Now, they weren't quite so nice. They didn't exactly give us the perfect square, but if they say solve using the square root property, it's a good clue that it is a perfect square. Square root of 36 is 6, square root of y squared is y, and once again, y times 6 times 2 is 12. So what do you know? It is a perfect square, so we can take the square root of both sides. Square root of 100 is 10, and we need the plus or minus. So subtract 6 from both sides, and I have negative 6 plus or minus 10. Negative 6 plus 10 is 4, and negative 6 minus 10 is negative 16. Okay, so they were nice again, and they gave me a perfect square on the left. So when I take the square root of both sides, I'm going to have x plus 9 equals plus or minus the square root of 8. Now, this book goes over how to simplify radicals in Chapter 11, and we're in Chapter 9. So for now, we're just going to say if you type it in your calculator, the Texas Instruments 30x's is, subtract 9 from both sides, square root of 8 will be 2 square root of 2. And the good news is they're not like terms. I can't combine them, so I am done. The square root property says for any number n is greater than 0, if x squared equals n, then x equals plus or minus the square root of n.